We look at this first graph. I'm going to call this graph, let's say graph A. So graph A, what do you notice about graph A? And I'm going to write this in white up here. You're right, good. Okay, the first highest. What do we call that? Because it's the first highest. What does it mean that that bar is high? The mode. The mode is the one that occurs the most. So mode, remember that one occurs the most, and it is 7. Okay? I'm sorry, what? I didn't say 6 anything. I don't think. I think Morgan said the second highest was 6 and 8. But the mode right here is 7. Okay? I'm sorry, what? Here we go again. Guys, whatever we had from yesterday, we don't want that today. Okay? We need to get through. All right. So, what else can you tell me? What about another measure of center? What can you tell me about another measure of center? Well, that's what I'm asking you. What's another measure of center that we could talk about for these graphs? We've got mode. We also have median. What is the median again? What does it mean? Okay, the middle. So median means middle. And what is the middle look to be for this graph? It also is 7. So we have the mode, the median, and finally we also have the, which is called, the formal name is the mean. Very good. The mean is the average. And if you look at this, I need to put the median here. So my median is also right here. That's your middle. The mean, where is my mean going to be? The average of all of those scores. What do you think? What? The average is going to be 4, 2, and 3? Is that what you said? 4 through 10. No. No. 7. How did you get 7? Do you know? Quiet, please. It's in the middle. That's part of it. Although we know middle is actually the median, right? But if you look at the heights for 4 and 10, let's say these are scores on a quiz, okay? So the same number of people scored 4 as the same number of people that scored a 10, right? So if I add these two together, I get 14, and 14 divided by 2 is 7. And if I notice, I have the same number that scored 5 as scored 9. If I add these together, 5 and 9 make 14. 14 divided by 2 is 7. And the same with 6 and 8. And the 7s are already there in the middle. So yes, my mean, if I would add them all up and divide by how many there are, is going to give me 7. Okay, I'm sorry, I didn't hear you, Rachel. Oh yeah, it should be graph A, not graph A, graph A. So what is it called when we have, what's the fancy mathematical term when we have one mode? Think of the fantastical animal that has a single horn. Unicorn, so this is called Unimodal. This is a unimodal graph, meaning it has one mode. U-N-I, and then modal, M-O-D-A-L. Sean, please put that away. So that means, we don't need you to tell him, I just did, one mode. Okay? So, unimodal. So, when we were looking at the mode, that's the one that happens the most. That was the blue line. The median, that would be a red line right over that. So, it actually would be the same line and also the same for the mean. They all come from the same place. So, when you have a unimodal graph, when you have, Gabe, you need to stay this way, and I would write down a few of these things. When you have a unimodal graph, and what's it called when you have the same thing to the left of your median as you have on the right? What's that called when it looks the same? It is balanced. What else though? Symmetric, yes, and that's the little word down here, symmetric. So when you have a unimodal graph that is symmetric, meaning it's the same on the right as it is on the left, then your mode is going to be the same as the mean, which is the same as the median. Okay, that's when it is unimodal, when you only have one. All right. Okay. So now let's go to graph B. Graph B. Now, I'm going to tell you something, and let's actually take a look at what these words say. Graph B, these words say it is skewed to the left. Skewed, that is a word you might not have heard before. And it says the tail, and I'm going to put that tail in quotes, pulls the mean down. Okay, so this is not symmetric anymore. It doesn't look the same on the right as it does the left. This part is the tail, and I want you to think of a beaver tail. Okay, it's long and flat, right? A beaver tail. So whatever side the tail is on, whatever side this tail is on, if the tail is on the left, that's when we say it is also skewed to the left. So the tail is on the left, it is skewed to the left. Okay? All right, so let's talk about what we think the most obvious thing here is, and I'm going to say that is the mode. The mode is 9, yes. Any question about that? It is the highest bar. It's the one that occurs the most often. All right, so my median, the middle, is no longer going to be in the middle because this is not symmetric. Do you think the median is going to be, as I write in, this is mode, and that's 9. Do you think the mean, the average, is going to be higher than that mode or lower, and why? I heard lower. Did you say lower? Lower. Okay. Gabe, stay with me. Anybody think higher? The median, the middle. Because when you're looking at the median, you're looking at the amount of purple, and you want to have the same amount of the purple area on the right as you do on the left. Well, obviously, this is less than this plus the tail, right? We haven't even done the tail part. So yes, the median is going to be less than the mode We don't know by how much, but we definitely know it's less than. Okay? You said what? I am going to put it right here. We don't know exactly, but it's definitely less. Okay? So this is my median. It's going to be pulled to the left in the direction of the tail. Okay? I'm going to say between 8 and 9. We really don't know. It's just approximate, but it's definitely lower. Okay? Then I also want to talk about my mean. Where do you think the average? Remember, these are scores. So what do you think my mean is going to be? Is the mean going to be, do you think to the right of the median or to the left of the median? The average, if these are all scores. To the right, you say to the left. Why do you say to the right? You always have to back it up in here. Yes, you said to the right. So as you look at these, where, these are high scores. These are the same, those would average out. This is going to average out with this. And then you've got all these scores over here. Those scores are lower, right? So they are going to pull your average down to the left. So that means your mean is going to be less than your median. And I'm going to say it's maybe about right here between 7 and 8. So let me get rid of these squiggles. Okay? So I'm going to say your mean, is about right here. All right? So when you have, what's that fancy term for a one-mode graph again? Unimodal. Okay. So let me get a different color here. When you have a unimodal graph, okay, usually, and this is usually, not always, but usually your mode is going to be greater than your median, which is going to be greater than your mean. So this tail is not only pulling the median down a little bit, it is really affecting the mean. It's really affecting the whole average. Okay? All right. And like it says here, the mean is less than the median. And we have said that, but we are saying the median is bigger. Okay? All right. And let's look at graph C. So if graph B was skewed to the left, what do you think graph C is going to be? Skewed to the right. So graph C is skewed to the right. Remember, skewed means in the direction of what looks like a tail. There's your tail. So again, let's start with mode. The mode is the one that occurs the most. It is 3. So I'm going to make a solid line here. Say that's my mode, and it is 3. My median, middle, is going to be what? That's right. You've got that tail right over here, and that tail is pulling the middle amount over to the right of your mode. So I'm going to say right here, between 3 and 4, I'm going to say that is your median. So the median is greater than the mode. greater than. Okay. And I'm going to say the median is between 3 and 4. And finally, the mean. Where am I going to find the mean? To the right or the left of the mode and the median? What do you think? To the right. Because you've got all these high scores. There's not a lot of high scores, but there's enough of them that they are pulling the average up. The average score up a little bit. So here's your mean. It is greater than the median and the mode. And I'm going to say it's between 4 and 5. These are all approximate because we don't know how many there are of each one. Okay? All right. Any questions about any of those? How you recognize the mean, the median, or the mode of them? Of any of them? Okay, so let's turn and go to page 17 and 18, and let's look at these graphs. 17 and 18. Now, these are written in Roman numerals, which is great if you know Roman numerals, but I think it's maybe simpler just to write them as 1, 2, 3, 4, 5, 6, and graph 7. Very good, Herman, very good. All right, so question number 1. See if I can find that. Says, which histogram has a mean? I need to carry this because I don't have the questions. Which histogram has a mean that is greater than its median? Which histogram has a mean that is greater than the median? Let's put the phones away, please. Everybody. Now, flip back to what we just did if you need to look. We want the mean to be greater than the median. Write down or jot down an answer. Again, flip back to page 11 if you're not sure. Mean is greater than the median. Mean greater than the median. That is for number 1. Well, you're looking at page 17 and 18. No. It's not for number 1. It answers question 1. You have to put 17 and 18 open together. So question 1 on page 18 says, where is the mean? Which graph shows the mean? So have them both open at the same time so you can see both pages. So which of these graphs shows the mean greater than the median? Please put away. Yeah, what do you think? That is not an option, but yes. Flip back to 11 if you've forgotten. Yes, what do you think? Graph 1. Why do you think the mean is greater than the median there? Because you've got this tail that's pulling it, right? So yes, I'm going to say graph 1. It is skewed to the right. Very good. Listen to that. Yes. Is there another one that is skewed to the right? 3. That is correct. So graph 1 and 3 have the mean larger than the median. Ooh. Stacy. You haven't used 1 at all yet, have you? Okay. Go to question number 2 and see if you can answer that one. As I am taking care of business over here. 10:15 is 10:15. Uh-huh. Okay. So, question 2. What does question 2 ask? Because I don't have it. Let's see. Well, okay, yes. Where is the mean equal to the median? 2 and what? All right, let's see. Mean equal to the median. 2, I would say yes. Graphs 2 and what? 2 and 5. Any others? Yes, 6. Very nice. Because they are what? Very good. They are all symmetric. Okay, so they are symmetric. That's what makes the mean equal to the median. And for number 1, they were all skewed to the right. For problem 1, graphs 1 and 3 were skewed to the right. Very good. All right. Problem number 3. Which histogram appears to have the smallest mean? Remember, mean means average. These are scores. Well, the smallest. So we want one graph.
What does that say, the blue?
Skewed to the right.
Skewed right, yes. Okay. The smallest average. 4. Now remember, these are scores. What's the highest score in 4? Graph 4. Let me ask this question first. Hang on. So Rachel, you said graph 4, but in graph 4, most of the scores are an 8. Graph 7. Where are most of the scores in graph 7? Most of the scores are still at 8, right? You said 6? Okay, so in 6, I see most of the scores. This is bimodal in 6. I see most of the scores are 1, and an equal number of those scores scored 9. So that's kind of average out to be in the middle. Where do you see the majority of the scores that are low? 2? No. 3, 4. Do I hear 4? 5, 6, 7. Okay, guys, listen. Where do you see the bulk or the majority of the scores down low? Low scores. Where do you see most of them that are low? 1. Yes. Look, right here in graph 1, the mode is 2. The bulk of your scores are right here. I circled the tail. It's definitely skewed right, but the majority of the scores are low. So the one with the lowest mean is graph 1. The lowest or smallest mean is graph 1. Does that make sense to you? No? If you were to circle the mode of each one of these, the mode is the one that happens the most, right? The only one that is closest to being low is graph 1. So the majority of these scores are all down low. Okay? All right. All right, so problem number 4. Which histogram appears to have the largest mean? So think opposite. 2 is better than 1, definitely. 5. What do you think the mean is for 5? Because it's symmetric, right? What's the mean for graph 5? I think there's one that's higher than 5. 7. 7 looks pretty good. I think there's one better than 7. I heard 6. These two are going to average out to be in the middle. I heard 7 and I heard 4. Look at 7 and 4. Which one is going to have the higher mean? Higher mean. I don't want the mean exactly, but which graph has the higher mean? This one has a break in here, right? And it's got some lower scores. This one doesn't have a break, and they're all clustered together. So which one is going to be the highest mean, 4 or 7? 4. Yes. So problem number 4, the highest mean is graph 4. Does that make sense to you? Seriously? Yes? Okay, if it doesn't, you got to let me know. All right, number 5. Which histogram appears to have the largest standard deviation? Largest standard deviation, the largest spread. Well, let's see. 6, graph 6 goes from 0 to 10. Does anything else go from 0 to 10? Actually, 7 does. But as you look at, is there anything else? Hey, so 6 or 7, which one has the largest spread, would you say? I'm going to say 6 because the majority of it is on the outside, right? So it is spread a little bit more. Although I think you could put in 6 or 7 because they both do go from 0 to 10. So I'm going to say graphs 6 and 7 have the largest spread. And the last one. Which histogram appears to have the smallest spread? Definitely 2. Yes, that is all clumped together, right? Small spread, that only goes from 3 to 7. So graph number 2 has the smallest, and remember that's called standard deviation. I'm just putting SD there, okay? Any questions on those? And I am recording this, okay? Any questions? All right, so next, take out your computers. No, we are not done. This is where we get to work on CODAP a little bit. Well, we're going to the computers. Yeah, keep your books open. Go to task 12 because task 12 is the golf scores of 2 golfers. Okay? And on your computers, listen please. On your computers, you need to type in this link, which is https:// quiet please, tinyurl.com / prime with a capital P, task with a capital T, and 12. Come on. This is where we are starting to work together, where you guys can learn how to manipulate things on CODAP. Erlyn, can you type it in? It's right there on the front part. So here is the problem as you are typing in this link. It says 2 golfers kept track of their scores over the course of a year. Their scores are given below. All courses played were 72 par. So it says for Roy, he has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. Minerva has 10 scores. who is the better golfer and why, explain your reason. We want to find for each of them the mean, the median, the range, and the standard deviation for both players. Now, if we had to calculate this all by ourselves, this would take a lot of time. But if you click, or if you put in this tinyurl.com/primetask12,